So, welcome to my talk. I'm going to talk about complex event processing with Esper. Um, I'm going to apologize. This is the first time I give this talk, so you're going to have to bear with me. Probably will be fine, but probably have some room to improve. I am Antonio Alegria. You can find me on Twitter with my Twitter handle. I work at Sapo at the big data team, and I have worked with complex event processing for some years now, mainly on business activity monitoring, just seeing if business processes are working fine, call centers are working fine at Portugal Telecom, and more recently at Sapo. So, complex event processing. Does anyone here is familiar with the term? Yeah? Okay. So, it's really intuitively, it's a very easy to understand term, and it was first coined in this book. This is like the Bible of complex event processing, and I highly recommend anyone to read it if you're really interested about in working with in event processing. If you're interested in really gathering meaning from a cloud of events, and so a complex event is simply an event that only happens because a lot of other simpler events happen. And complex event processing is just a tool or a set of techniques to control all these events, these very simple events, and infer more complex events and just process them, analyze them, and use them to better drive your business. And so you can talk about complex events like a business transaction. A business transaction is composed of a transaction initialization and a transaction ending. So, and in the middle, you have a lot of steps in that business process. So, for example, I'm going to give a very naive example of a complex event. Imagine you have an event telling you a church bell is ringing. And then you have an event telling you that you have a man in a tuxedo, a woman in a white gown, and rice is flying through the air. What can you infer from this? Well, you can infer a complex event that is a wedding has happened. This is really useless, actually, but it's just to give you a clear image of what a complex event is. This is an example I took from Wikipedia, which I thought really represented what a complex event is. And so, but there are other complex event processing use cases. I have worked thoroughly on business process monitoring. Are your call centers working on time? Are your call center operators dealing with the calls on time? And are your systems really forwarding the calls at the time you really need them to be? So you are monitoring all the events, call waiting, call arriving, call ended, and you are inferring larger transactions of talks with your clients, and you are, for example, measuring the time it takes for each call, how long it takes for the operator to answer the call, and that's really key for real-time business optimization. This is also used thoroughly in high-frequency trading. Most companies these days, they are dealing with stocks and securities, use automatic systems to really find opportunities for arbitrage. And they detect that, for instance, a stock is going down and it has reached a bottom and it's going up. So I'm going to buy it now. I'm going to buy at a low price, or I'm going to sell at a high price. And you need to do this. You need to really hear the stocks at a real time and really infer events of more than one stock. For instance, you detect that the market is crashing. You need to look at a lot of stocks, right? So I've talked about the call center, and another interesting use case is intrusion detection. If you look at your logs or your access logs to your systems, or syslog, all your logs from your sysadmin operations, you can clearly, if a human is looking at the logs and he is like superhuman, he can really read the matrix, he will be able to detect there's a breach here. This is fishy. This behavior is fishy. This guy is trying to log in a lot of time and failing. But what would be ideal if you do this in real time, you're looking at these events and the complex pattern of events to detect that there's a security breach. And so these are some of the use cases where SEP is used. So complex event processing is actually not a technology. It's more of a concept. Although many times people use generally the term complex event processing systems to define those tools that enable you to better use this concept. And so it's maybe you could say it's a buzzword like service-oriented architectures, right? But a lot of enterprise vendors like Oracle or Sybase and Microsoft have already adopted in their enterprise like business processing monitoring frameworks and tools the complex event processing term. And it has been subject to some commercialization fuzz. But actually, it's, like I said, a conceptual framework of how to deal with an event cloud. And it's an architectural pattern. I propose here an event-driven architecture where complex event processing really makes sense. So you have the event cloud. This is just a cloud of events. You have your system logs. You have your business process logs. You have stock ticks coming into your system. This is a cloud. You have, for instance, tweets. If you want to analyze tweets, they're coming into your system. You put them in a messaging bus, right? You have event preprocessors, which just read the events and transform it and normalize it so that your domain fits with it. And you also have passive data, which is historical data that business maybe uses to run reports and really explore data. But here what I'm going to talk about more is the complex event processors, which are able, given a lot of events, to detect patterns and infer higher order events. And so the goal here is really the UI part. You can see the UI, it's like a general term. You have alerts, and this is like the crucial part in running your business in real time and a tactical level. Business, CEOs or management really wants alerts. They don't want to be spending all day looking at dashboards. A lot of companies have like beautiful dashboards on their corridors and they're really happy. Hey, we have monitoring. We really know what's happening in our business because we have pretty graphs on the wall. But man, it's really not optimized. You really want to know just when things happen. When shit happens, you want to know it right that second. And you don't want to be pulling the graphs on the charts. But it's obviously important. And then you have the reports, which focus more on passive data. But here I'm going to talk more about the complex event processors, of which Esper is a great tool to build them. So what do you need for a complex event processing system? What are the main requirements, or what are the main qualities? So naturally, it has to be event-driven. You don't want to pull your data. So you could say, well, I have an amazing Hadoop system. It's distributed, and I have a HBase, and I can do real-time metrics. But what you're really doing, you're polling continuously. And it can be very quick, but you're not driven by data. You're not data-driven. You're polling constantly and processing the data. We don't want that. We want the events to drive our system, which means we want our system to be real-time. And when I talk about real-time, I'm talking about soft real-time. And actually, if I'm going to be really honest, what I mean is right time. I want to receive the information, and I want to detect the events, the complex events, at the right time that I need to deal with them. Maybe I don't need to know about a security breach right that nanosecond, but I probably want to know it right that minute. If I'm trading stocks, I want to deal with arbitrage opportunities right that nanosecond because I'm dealing with a lot of money, and 1 millisecond late, I am competing with other companies. 1 millisecond late could be millions of dollars of lost money. Another important feature or quality is that SEP deals with all layers of an organization or of a system. So it's not just about the basic events of, for instance, your information systems, your server logs. It deals with transactions, it deals with business operations, and you want to deal with all the layers of the organization, and you want to be able to relate each layer with one another. You want to have causality. You want to aggregate events because you probably don't want to deal with all that mass, all the event cloud, which is massive and it's continuously arriving. So you want to summarize some events. For instance, a way to summarize an event is to calculate an average over a time period. Okay, I don't want to know about all events coming last minute. I just want to know an average so I can deal with it, right? A very important part of SAP is event relationships. This is what really differentiates it. And first we have causality. We want to know that event A caused event B, right? We want to know that logging into that system or doing that business transaction originated a supply chain, let's say, missing materials, because I have a lot of events, I have a lot of demand, for instance, and that will cause my supply chain to become unbalanced. So it's really about detecting that one event causes the other. Another is membership. An event belongs to another event, and another very important characteristic is timing. I want to relate events by timing. This event came before that event. It's a little like causality, but it's really not. Just that event came before the other, and it's important to deal with timing. So, this all comes down to event patterns. You need to be able to detect and deal with event patterns. You need to, like I said, just detect a security breach, detect an opportunity for arbitrage. And finally, you need to have a domain-specific language for event processing. Why do you need a domain-specific language? Well, it's really hard if you don't. I mean, you want to specify the patterns, you want to specify the relationships, you want to specify the inferred events and the event hierarchies with an optimized language for that. Otherwise, it's really hard, and you cannot express exactly what you want to do right that instance. So it's more trouble for the programmer, and it's harder then to debug and to evolve the system. So to summarize, what you need for SAP is you need a system that it's event driven, that responds right at the time it needs to, and works across all layers of the organization, and is able to aggregate, correlate, and trace events. What I mean by trace is, if you infer a complex event, you need to know that that event was inferred from the other basic events. So you can trace, you can drill down effectively. That's really important, because if you want to understand, okay, you get an alert. Okay, I know there was a security breach, but you want to understand, so you have to drill down and explore exactly what happened. You need patterns, and you need a DSL. Okay. So, furthermore, a complex event processing system generally has all these operations. It has windowing, so you can say that I want to look at events in a 5-minute time window or in a 1,000 event window. You have to be able to transform them, to aggregate and group them, to merge them, to filter them, to sort them, to correlate them, and to detect patterns. So basically, everything you would want to do with a set operations, but on an event stream and on a continuous basis. And so for this, I'm going to talk about Esper. So Esper is a commercial / open source project. You can use the open source version, but they also have a commercial version. It's written in Java, but for some people that's a big minus. But I want you to think about it's actually running on the JVM. So that's the important part, because then you can extend it with Scala, with Clojure, with JRuby, which is actually what I have done in my work. I have extended it with JRuby and Scala. So that's a big plus. It's really low latency, and it handles high throughput of events. And it is able to deal with a lot of rules. So you can have thousands, hundreds of thousands of rules, and it is optimized to find the ones that will match your event stream. So that's really cool. And finally, the most important part is the domain specific language I was talking about. It has the event processing language, which is something like SQL, but is made for processing streams and handling with stream sets. And in the reference architecture I talked previously, I will put Esper in the complex event processors area. Okay? And Esper has support to deal with passive data. You can integrate your metadata or historical data in your continuous processing. And so that's where it fits in. It really makes it easier to build a SAP app. You could do it all by yourself. You can write it from the ground up. But hey, this makes it, this gives you all the operations you need. This gives you the language. And this gives you the performance. So you should just use it, at least to get started with all these things. You don't need no glue code. You can easily apply filters and aggregations. And Esper automatically maintains only the data you need and expires the event you don't need it. So if you write a query where you want all the events in the last 5 minutes, it automatically expires the events that are older than 6 minutes. You don't have to manually expire them. So that's really useful to build event processing systems without worries. And some similarities can be made from Esper to databases. I'm mostly talking about SQL databases, but you can also talk about the NoSQL. It's not meant to replace it. It's meant to complement it. As you see, you have passive data. It's more static data. It's data you pull. And then you have event streams. Some parallels can be made. So Esper stores queries, whereas databases normally store data, right? And so the events come into Esper, and instead of you having your data and you're querying it, you're pulling it, no, actually you have your queries stored, and the data goes through the queries. And Esper will match them and say, okay, this event matches this query, and so we'll produce this output. It's continuous versus on demand, like I said. Streams go through queries. On the database, you have to pull, you have to request data. Unless you use triggers, but let's not go there. And another important difference is time is a crucial dimension in Esper, where in database, it's just a data type. And this is very important because you are dealing with timing relationships between events, and you want that optimized, and you want that built in so that it's easy for you to use. Another parallel you can do is Esper as EPL, event processing language, and databases, namely SQL databases, have SQL. Esper has event streams, whereas databases have tables, and Esper has events where databases have rows. So these are the parallels and the differences. The processing model is very simple. So you have your input adapters, which Esper comes with some. It comes with a CSV input adapter. It comes with JMS input adapters. But I don't really recommend if you're really serious about building this, because they are not very flexible. So you will want to build your input adapters, which is it's really easy. Really, you could build your input adapters for ZeroMQ, for ActiveMQ, for RabbitMQ, whatever. And so these input adapters inject the events into the engine for continuous processing. And so the events must be of a certain defined event type and will run continuously through the rules you define. And you also have an historical data access layer. Okay, so what happens when rules match? Well, if you are interested in the results of a certain rule, you have to subscribe a certain object, which we call a rule subscriber, to it. And it might fire an action or actually forward it to an output adapter, and it will be injected into your messaging bus for you to use later. Okay, so I'm going to talk about event processing language, and I'm going to use a use case of Twitter. I chose Twitter because it's very easy for you to access the events, and if you want to play around with this a bit, you just fire the streaming API and you play with it. Okay, it's not really about being a very useful use case, although many people are trying to deal with Twitter events. And so let's go into event definitions. There are many ways to define event types in Esper. You can do it via API, you could in Java or whatever, and you say, okay, I have this event type with these fields, or you can do it the way I prefer it via EPL. You have in the language support for this. So you can see here that I actually have type inheritance, which you'll see further down. That's very important. Most events should have a timestamp, right? Because, like I said, timing is important. And so we have a tweet which has a user, has the text, which is the status text, and it has like a flag saying if it's a retweet of another tweet or not. We also have the hashtag. So the hashtag is an occurrence of an hashtag in a Twitter stream. So it just says in which tweet did it appear, which user posted it, and what is the hashtag. It also inherits from event, which means it also has an ID and it also has a timestamp. Furthermore, we have the URL, which is the same as an hashtag, so it's a copy from, and a mention. It's basically you detect that there was a user mention in a Twitter stream, and you detect that was a URL in a Twitter stream, and you can trace it back to the tweet it originated from. Something I have to mention also is that Esper allows you to define event representations in different ways. Events can be represented by a plain old Java object, or it can be a map, like a hash map. That's really the way I prefer to use it because it's more dynamic. I don't have to define a class for it. I just define a hash map with the fields I want, and that's the event type, right? You can also have XML. If you have a more enterprise system and you don't want to pre-process the events, which I don't really recommend, you can just pipe the XML events into Esper, and it will know what to do with the fields, and you can also use XPath. So there are a lot of ways of reifying the events you define here. And so, like I said, EPL looks like SQL, right? But instead of tables, you have event streams. So as you can see here, this will allow you to select all events coming into Esper, into this Esper system. If you want to select only the tweets, you select the tweet type, okay? And so here you can see an example of polymorphic rules in that tweet inherits from event, and I can just query for event and I have all events, or I can query for tweet and I have just the tweets. So filtering. Let's imagine we want to know, we want to get, and we want to process all the tweets posted by Codebits. Pretty simple. We have two ways of doing that. Above, we directly apply that to the event stream. So we want to create a stream which is only from tweets, whose user is Codebits, or we just do a post filter. So this is a pre-filter, and this is a post filter. We use where, like in SQL. We can do some more complex filters. For example, below, we are trying to find all Codebits hashtags not posted by Codebits. So what are people that are not Codebits posting about Codebits? It's really simple. And then later, you can select directly from it. Aggregation. So let's say we want to calculate in real time what is the rate of URLs that are being published on Twitter. So first, we are receiving just atomic events saying that at this time, this URL was posted on Twitter by this user. Okay? So first, what we do is we aggregate on a time window of 1 second how many URLs were posted. So this is very similar to SQL. You have a count star. You will realize that .win time batch is a little different. We'll go into it next. And then we process that URLs per second, and we aggregate on length window of 60. So we have 60 seconds of URLs, and we just see the average of URLs that are posted to Twitter per minute. Right? Okay. Grouping. This is another important operation. Beforehand, we were seeing what is the rate of URLs that are published to Twitter. All URLs. I don't care what URL. What is the rate of URLs? Okay, now I want to know for each hashtag how many of them are being posted in a 30-second window. So I will probably use this if I want to know the top hashtags in the last 30 seconds. So as you can see, we have here what we call an event window, right? This defines a window or a view over the full event stream. Let's imagine we have the full event stream and we just want to lock a subset of them like this, and this is a window. And this is a time window of 30 seconds. And we have a lot of windows. We have the time window, where first we have a 5-minute sliding window. By default, win time defines a sliding window that's 5 minutes from now, and it's always sliding. And we have the time batch, which is a tumbling window, which means that you have 1 minute and 1 minute and 1 minute, right? So the first one is continuous. So if you do this, you are always updating the query because time doesn't stop. The other one only posts, in this case, each hour one time, okay? Then you have length. It's the same thing. It's instead of time, you're talking about length of events. 10 events, 1,000 of events. And you also have a sliding window, length, and you have a tumbling window with length batch. Esper also gives you other standard event views. You have ext timed, which allows you to not use the system clock. So beforehand, we have win time, which means for the last 5 minutes, according to the system time, the system clock, I want you to give me that window of events. But let's say you don't want to use the system clock and you want to use the timestamps that come in the events. Then you say, okay, I want you to give me a window of 5 minutes of events based on the timestamps that come on the events themselves. You also have a window like group win. And this window basically splits the event streams for each key, in this case user. So you have all the tweets and you want to split, create sub streams for each user, you use group win. And as you can see, you can chain the views. And so if you want to know the last 10 tweets per user, you split for each user and then you put a length of 10. So basically you have last 10 tweets per user. And if you want to know the top 5 hashtags, you have a very useful window that is sort. So sort just tells it, give me the 5 with a limit of 5 based on that attribute that's count on the descending order. So it's pretty simple. You have a lot of other views. You have unique, which it's like group win with a length of 1. You have statistic windows, views that basically automatically calculate statistics like averages, standard deviations, the data points. You have windows for calculating correlation between events. You have a lot of different windows, and furthermore, you can create your own custom views. For instance, I created a custom view that basically calculated the tricks index. I don't know if anyone is familiar with this. This is from technical analysis and stock market trading. And I used it. I created this custom window in order to detect trends. Because a trend is not just the top 5, for instance, hashtags. The trending topic is not the top 5 topics. It's the topics that are growing the most. And so the stock markets have a lot of index to calculate things like this. And so I just implemented a tricks index in a view, and basically it would give me the tricks value or the trending value for each event that's going into it. You could also use it sorry, just going back, you can also use it for a custom view that injects sentiment analysis into the events. Let's say, so events go through that window and it injects like if it's a good sentiment or a bad sentiment. So that's the way you could extend Esper. Okay, correlation. This is very important. We want, if we're talking about complex events, we need to be able to relate them with each other. And so if we want to know which hashtags describe a URL, I'm sorry, I don't have syntax highlighting. I know it's a little hard, but let's try and understand this. So what this is, what you see here, that I'm selecting two streams. This window, by the way, is just the last event, because in a join you have to specify a window always. This is a cross join. And be very careful about this, because what this means is if any event comes through here, matching this, it will generate an event. In this case, it's not very important because we just have last event. But imagine if we had here like a 5-minute window and a 5-minute window, and in those windows we have like 1,000,000 events, and we cross-join them, you can have a Cartesian product of them. So that can really explode. Okay, but here what we're doing is we're joining every URL that comes in with every hashtag in which their tweet ID is the same. So they both came from the same tweet, so we can assume that that hashtag relates to that URL. Okay, and we insert them into a stream called URL tags. Okay, so we have that stream called URL tags, and now we can calculate how many of these tags are associated with each URL. So here we group by URL and hashtag, and we count them for 1 hour. So in this hour, I know that, for instance, the Codebits hashtag is associated 10 times with the Codebits URL. Okay? And what is this for? Well, this is useful if you want to know for every minute what are the top 3 hashtags per URL. So I'm going to introduce here another thing. But basically, if you forget about this, you are just wanting to receive the top 3 hashtags, hashtag URL matchings in the last hour. The difference here, as I said, is that this is always matching at the time that new events come in. So if there's a change in that value, for instance, now a lot of URLs from Codebits with the hashtag Codebits has come on, and it has entered in the top 3, this will update. And so I want to control the output. And I say that, okay, just give me the results every minute, on the 0, you know? And so this is like a cron expression, and which says output the contents of this stream at this time, okay? That's what output snapshot does. You could also do output all every 3 minutes, whatever. You have a lot of flexibility in controlling the output. So, event patterns. This is where it gets interesting. Let's say we want to measure, we have an analytics system on tweets. We are a marketing company, and we want to know how long do users take to respond to our tweets? What's the engagement? Okay, so this is a very simple pattern which could also be used, for instance, to measure transactions. Patterns are great for transactions, where you detect the transaction beginning, you detect a lot of steps in the middle, you detect the transaction ending, and you can, for instance, calculate the time between both nodes. And here, I think if you look at it, it's really intuitive. You know, for every tweet that's followed by a mention referring to the same user, you can say that that was a response to that tweet, okay? And so then what you do is you calculate the time between the both of them, okay? So let's say I tweet, hey, I have a huge promotion here. I'm going to give you 50% off of Red Bull. Yeah, despite being free. I'm going to do that. And I want to know if people are responding to my tweet. I want to tweak it, you know. And so the system receives my tweet, and it waits for every mention of my user after that tweet. And so I assume it could be that it's not correct, but I assume that it's a response to my tweet. It's an engagement metric, and so I'm going to measure how much does it take for users to respond to me. Okay, another very useful pattern that's used is detecting missing events. And now this is a really sometimes a hard thing to do in most systems, because how do you detect that an event didn't happen? This is important. And you can also say that a missing event is an event in itself, right? This is a bit controversial, but I firmly believe in it. So if an event doesn't happen, it's an event. Okay, so here what I'm doing is for every tweet that's followed by a 1 hour interval in which there was no other tweet from me, I can assume that that's a missing event. My marketing company should tweet every hour. So I'm going to alert someone about this. And when I say this, this is really not really useful, but if you think about, for instance, your servers, and you think, okay, my servers are supposed to send logs to the log management system constantly, and I want to detect when that doesn't happen. Maybe there was a problem, and I want to know it right that second. I don't want to have to run a 5-minute query to detect it. So this is really crucial. And if you build a slightly complex event processing use case, you will need to do this. There are many other features that I hardly could have crammed into here. You could use subqueries like in SQL. You more than those cross joins that I talk about, you could also use inner and outer joins, which, if the semantic meaning of them is what you want, is better to use, because they are, instead of being a Cartesian product, you have something much more optimized, and it's dependent of just one of the streams. Furthermore, you have named windows, which allow you to store state about an event stream. Let's say you want to keep all tweets regardless of timing, and you want to delete some of them, for instance, when you receive an event about clear tweets, let's say. So you have an you have a named window where you have all tweets, and you can name that window and that event stream, and you say, okay, remove those events. You also have first-class integration with databases via JDBC, so you can access your historical data and you can access metadata. And this is relevant mostly if you want to use baselines. So you're not going to hard code, for instance, quality of service metrics alarms by putting a value. For instance, you have a system that must respond in 5 seconds. Okay, so you're hard coding 5 seconds, but what you want to receive an alarm for is if that system goes below the baseline more than 10%, for instance. Because imagine if the system is bad the whole week, you don't want to receive alarms the whole week because you already know about it. So you will really want to know. You really want to work with baselines, and so those baselines are historical data, and so you could integrate it using JDBC, and that's really easy to integrate into the rules. Furthermore, you have another syntax for event patterns matching, which is it's really similar with regular expressions. You almost say like, okay, this event is A, this event is B, and I want to detect the pattern A, B star, for instance. And this is what in Esper jargon they call match recognize patterns. So in summary, Esper is awesome, but it's not a silver bullet. Duh, right? First, there's the major problem here, and it's the easiest to point. It's memory usage. So this really works in memory, which is its advantage because it's really fast and it's real time. However, you very easily can shoot yourself in the foot. For instance, with those cross joins, you can really have an explosion, a correlation explosion, where you just blow up with a JVM stack. Happened to me a lot of times. And really what you have to realize is you have to use Esper specifically for things that are happening right now. You shouldn't really store a lot of state because this is all in memory, and you should use Esper with other systems. You should integrate it, for instance, with your historical data store, and but this is a real issue, and Esper doesn't really integrate with like I don't know, a second level event stream storage that's streaming, but it's not really in memory. It doesn't integrate with it. So if you want to do it, you have to extend it, which they have support in the API for you to, for instance, implement another support for an event stream, for instance, over MongoDB, let's say. But this is a real problem. Another problem that's related to it is resilience and persistence. So everything is in memory, and in the open source version, if there's a crash, things go wrong, right? If there's a crash, you lose all the state, and that, especially if you're detecting some long-running patterns. For instance, a transaction that's running for 1 hour, and you detected that the transaction began, you detected the middle steps, and then the server goes down. When the server goes up again, you lost that transaction. And in many cases, that's okay, but in some cases where you're talking about, for instance, fraud detection or business activity monitoring, it can be a really big fault. In the commercial version, they have what they call the high availability Esper, where they solve it by clustering Esper and also by allowing you to store named windows, which I talked about previously, into persistent storage. So if the server crashes, let's say we back up those windows, I don't know, periodically. If the server goes down, you can recover state, which is good, and you can also implement it, I guess, but it's not built in. And I'm defending Esper because it has a lot of good things built in, right? Pattern matching could be better. I mean, if you compare it with something like Drools Fusion, which really oh man, I forgot, a rules engine, right? It has event pattern matching that is much better and much more powerful, or if you compare it with something like Prolog or whatever. And that syntax is good to detect things that have some kind of very linear causal timing relationship, but it could be much better. You can work around it by defining your own extensions if you want to embed some logic into the pattern matching, but this could be much better. Another thing is that drill down is not trivial. Okay, Esper, despite being a complex event processing system, it really doesn't deliver on the drill down part. On a native, it natively doesn't support drill down. What I mean by this is that when you correlate two events and you create another one that's complex, it doesn't natively allow you to know that that event you generated came from those other two. You have to build that into your own rules, and that is not trivial, and you have a lot of problems because of memory. Furthermore, because if you have to trace all those steps further down to the more basic events, and you're holding this all into memory, you're going to have an event graph that could be monstrous. Okay. Finally, it's not finally. Forget about it. It's not distributed. Okay. So nowadays you have the servers in Amazon. You are used to Hadoop and things like that, distributed processing, and Esper built-in does not support this. And this is a bummer, actually, because we are talking about really high-scaled event streams. This is a lot of data you have to process, and so you should be able to distribute it easily if you want to process them in time, right? It's really not that dramatic. As I said, the commercial version has a high availability system that's clustered, but you can. I have already made experiments in building my own distribution with Esper. If you really build an event-driven architecture around it, and you have your event topics, you can build something like a map-reduced complex event processing architecture, where you have Esper engines and rules that are responsible for just doing the map part, just aggregating the initial, you have a lot of URL occurrences, and these rules in these nodes are only worried about counting how many URLs were per minute, and you can shard it by URL or by URL range. And then you have the reduce, which will probably, I don't know, just correlate them, and you have successfully less event Esper engines, but you have to build it. It's not built in, and my dream is that I will have the patience to build like an open source system that already gives you this. And if anyone is interested in helping, I would be glad to do it. And finally, this is really finally, I'm really doing it on time. It's impressive. It's not full stack. Okay, what I mean by this is that it's just the complex event processing engine, right? So you don't have the charts, you don't have the alerting system, and that you have to build. And we're not talking about just simple charts that you take off from your historical database. What I would like to have is real-time charts. There's a company in Portugal that's called FeedsEye, and they have a complex event processing engine, just like Esper, similar, but they are full stack. And so you have a JavaScript library that automatically connects to the engines and can give you real-time charts on your business operation. For instance, they have something in the United States where they are monitoring the wind-generated power, infrastructure, and they know at the second what is the power that's being generated and at what price is it being sold, because that company is interested in doing arbitrage with energy production, because they can sell nickel and they can buy energy. And so nowadays people are used to Rails and other kinds of frameworks, and this is also a dream of mine. I want to build a full stack solution where it's just a turnkey, and you have everything from the charts and the alerts down to the event processing language, down to the storage, down to the distribution, and it's just easy to build. Because otherwise you're going to have a lot of work, but that's life. Okay, I will take your questions now. If you have something more deep to ask, you can contact me on Twitter or talk to me here. I would really appreciate your feedback and your questions. So let's hear it. No questions. That's really bad. Really bad. Yeah.
Como é que alimentas o mecanismo do Esper baseado em trapos, por exemplo? No Twitter tinha de fazer polling, mas baseado em trapos.
Okay, so
Faz o polling.
no. Okay. So the question was, how do I, if I understood it correctly, how do you inject the Twitter events into Esper without doing polling? Is that it? No? Not really. What I use here is the Twitter streaming API, where they maintain an open connection, and Twitter actually pushes the events to me. Okay. Okay, so I'm going to show you here the architecture I was talking about. I should have a music here. Okay. So Esper really is that processing engine. You have to inject by yourself. There is an API. You have a method called send event, and you have to call that method to inject the event. It's your responsibility to build. You have an agent that's listening to the Twitter streaming API, and I recommend that you directly inject that event into the messaging bus. And then you will have an event preprocessor that will read those events and generate, for instance, the tweet event, the URL event, the hashtag event, the mention event, okay? And then in Esper, you have what I showed here are the input adapters. You have an input adapter that's generic, actually. You're just listening to a topic on your messaging bus, and you're just getting that event. and putting it into Esper. Maybe you're getting that event in JSON, you convert JSON to a hash map, and you send it to Esper. It's really that simple. You just have to know what the name of the event is, and the name and the format you pass into must match what the event definition you put there. I don't know if it answers your question. You have to do it, basically. And that architecture I showed, I think, makes it much easier. Okay?
The throughput in using Esper processing model and other models. What, do you have any comparison?
Okay. I really don't have numbers here. You can, I could give you later, but Esper, they claim to have like they can process hundreds of thousands of events per second. That really depends on the rules you're doing. That's like everything, because if you do very complex rules, we do a lot of joins, which will create a lot of complex events, it will be slower, right? But if you keep it simple, and like I said, you have to be aware that you're dealing with in-memory storage. You have really great throughput and especially low latency. Compared to other systems like Jules Fusion or Streambase, which is a commercial product, I think it's really competitive. Okay, I can't really give you a number because it really depends on the rules.
You're talking about more than one communication channel,
Sim.
isn't it?
Desculpa, repito.
Quando falas em não ser distribuído, é ter apenas um message bus.
Okay.
Os message bus não têm as mensagens. Se fosse distribuído, provavelmente tinhas mais do que um.
Okay, so the question is, when I'm talking about it's not being distributed, am I talking about having just a single messaging bus for the events? No, it's not. It's not really what I'm talking about. You can have a distributed messaging bus. Okay, the problem here is that Esper doesn't give you native tools to have your rules and automatically distribute it over many engines. And these engines could be placed on a lot of servers. Okay, so these rules are running on that engine in one JVM. Okay, you can have a lot of engines and you can have a lot of servers, but it has to be you that has to forward and pipe the events from one engine to the other and coordinate them, and that's not easy. Okay, that's the problem. But if you could map, and you can, but there's performance issues. If you could map your event streams directly to topics in your messaging bus, and let's assume your messaging bus is distributed, which easily any modern one is, you could conceivably have a very easy to build distributed Esper system. So when I talk about distributed, I'm talking about the Esper engines being distributed over many machines. Okay, and coordinating the rules over those engines. Okay, you have built-in input adapters like JMS. So yes, you have automatic dispatchers. It really, but you have to define. Okay, this engine is subscribing to this event topic. That engine is subscribing to those topics. Okay, you don't have an automatic distribution over Esper engines. That's, I don't know if we can talk later. I mean, and you can take all it up. Okay. No, sure. We can talk afterwards. Okay, we have 6 minutes and a half or less because we have another speaker. Any other questions? Okay. Okay, in SAP, what are we using Esper for? Okay, to be honest, in SAP, we are not really using Esper for much. I have used Esper more. I was already in PT, in Portugal Telecom, then I went to SAP. It was before I went to SAP that I worked a lot with Esper. There is some usage of Esper in SAP, but it's not really that big a deal. And I'm trying. I've recently gone to the what you could call the big data team. It's not really well defined. And I'm trying to see if we can introduce it in an alerting system we have. It's SAP Alertas. and I think the matching engine could be very easily built with Esper. Furthermore, I would really love to take advantage of all the events that are going through SAP, because they already have a distributed messaging infrastructure with SAP Broker, and I think there's a great opportunity there, and I don't think it's really being taken advantage of. Okay. Any other questions? Come on, people. No? Okay. Okay. Thank you. Every feedback is welcome. You have my Twitter handle. So, thank you for listening.